Google builds an AI model that can predict future weather catastrophes. A new system uses generative AI to predict weather faster and more cheaply than ever, while detecting difficult to spot extreme weather events, beating the world's major weather agencies. Google released an artificial intelligence AI model, and it claims it can generate accurate weather forecasts at scale, while being cheaper than conventional physics-based forecasting. The scalable and ensemble envelope diffusion sampler, SEEDS for short, model is designed similarly to popular large models, language models, LLMs like ChatGPT, and generative AI tools like Sora, which generates videos from text prompts. SEEDS generates many ensembles or multiple weather scenarios much quicker and cheaper than traditional predictions models can. The team describes its findings in a paper published March 29 in the journal Science Advances. Whether it's difficult to predict, it's difficult, and in many variables that can lead to potentially devastating results, weather events, from hurricanes to heat waves. As climate change worsens and extreme weather events become more common, accurately predicting the weather can save lives by giving people time to prepare for the worst effects of natural disasters. Physics-based predictions currently used by weather services collect various measurements and give a final prediction that averages many different modeling predictions or an ensemble based on all the variables. Instead of a single forecast, weather forecasting is based on a set of predictions per forecast cycle that provides a range of possible future states. This means most weather predictions are accurate enough for more common conditions like mild weather or warm summer days, but generating enough forecast models to find the likely outcome of an extreme weather event is out of the reach of most services. Current predictions also use deterministic or probabilistic forecasting models in which random variables are introduced to the initial conditions, but this leads to a rapidly higher error rate, meaning that accurately predicting extreme weather further in the future is hard to get right. Unforeseen errors in the initial conditions can also vastly affect the prediction outcomes as the variables grow exponentially over time, and modeling enough forecasts to account for variables down to such minute details is expensive. The Google scientists estimate that 10,000 predictions in a model are needed to forecast events that are only 1% likely to happen. SEEDS produces prediction models from physical measurements collected by weather agencies. In particular, it looks at the relationship between the potential energy unit per mass of Earth's gravity field in the mid-troposphere and sea level pressure, two common measures used in forecasting. Traditional methods only feasibly produce ensembles of around 10 to 50 predictions, but by using AI, the current version of SEEDS can extrapolate up to 31 predictions ensembles based on just one or two seeding forecasts used as the input data. The researchers tested the system by modeling the 2022 European heat wave using historical weather data recorded at the time. Just 7 days before the heat wave, the U.S. operational ensemble prediction data gave no indication such an event was on the horizon. Google representatives said in the blog post of its research portal, they added that ensembles with less than 100 predictions, which is more than conventional, would also have missed it. The scientists described the computing costs associated with performing calculations with SEEDS as negligible compared with today's methods. Google says the AI system also has a throughput of 256 ensembles for every 3 minutes of processing time in a sample Google Cloud architecture, which can be scaled easily by recruiting more accelerators. Can you imagine? This is by Drew Turney on Live Science. Please leave your comments, and thank you for your support. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.